Nothing can go faster than light. You've heard this before. It's one of those facts that everyone knows. 186,000 miles per second, 300 million meters per second, the cosmic speed limit. But have you ever stopped to ask why? Why does speed have a limit at all? What's stopping you from just going faster and faster forever? Your brain probably imagines something like a wall, like you hit some barrier in space and can't push through. Or maybe you think it's about engines, about not having enough power. But that's not it. Not even close. The truth is so much stranger, so much deeper. And Richard Feynman, one of the greatest physicists who ever lived, saw through to the heart of it. Let me show you what he found. Here's what most people think. They think the speed of light is just a really big number, a cosmic speed limit sign posted by the universe. But that's not what it is. The speed of light isn't just fast. It's not just the fastest thing we've measured. The speed of light is woven into the fabric of reality itself. It's not a speed at all, not really. It's something else entirely. And once you see what it actually is, your understanding of the universe will never be the same. Let me start with something that will sound insane. The speed of light is the same for everyone. No matter how fast you're moving, no matter what direction you're going, no matter what. You could be standing still. You could be flying through space at 99% the speed of light. Doesn't matter. If you measure the speed of light, you always get the same number. Always. This is not obvious. This is not intuitive. This is completely insane. Think about it. Imagine you're standing on the side of a road, and a car drives past you at 60 miles per hour. Now imagine you're in your own car driving at 50 miles per hour in the same direction. How fast is that other car moving relative to you? 10 miles per hour, right? You subtract the speeds. That's how motion works. That's how everything in your daily life works. Velocities add and subtract. If you're moving toward something, it appears faster. If you're moving away, it appears slower. This is common sense. But light doesn't do this. Light breaks this rule completely. If you're standing still and you measure a beam of light, it's going 186,000 miles per second. If you're flying toward that same beam at 100,000 miles per second, you measure it again. What speed do you get? Still 186,000 miles per second. Not faster, not 286,000, the same, exactly the same. If you're flying away from the light at 100,000 miles per second, you measure it again. Still 186,000 miles per second. Not slower, the same. This is not a measurement error. This is not an illusion. This is reality. Light moves at the same speed relative to everyone, no matter how fast they're moving. And this fact, this one weird fact, breaks everything. It shatters all your intuitions about space and time and motion. Because if light always moves at the same speed, then something else has to give. Something has to be flexible. And what gives is space and time themselves. Here's what Feynman realized. Here's the key insight that changes everything. The speed of light isn't really about light. It's about the structure of space-time. It's about the relationship between space and time, between distance and duration. The speed of light is the conversion factor. It's the exchange rate between space and time. Let me explain what that means. You think of space and time as separate things. You think of space as the place where things are, and time as the thing that flows forward, second by second. But they're not separate. They're woven together. Einstein showed us this. Space and time are part of one unified thing called space-time, and the speed of light is the number that connects them. It tells you how much space equals how much time. Here's an analogy. Think about currency exchange. $1 and €1 are different, but they're connected by an exchange rate. You can convert dollars to euros and back. The exchange rate tells you how many of one equals how many of the other. The speed of light is like that. It's the exchange rate between space and time. It tells you how many meters of space equal how many seconds of time. And here's the crazy part. That exchange rate is built into the universe. It's not arbitrary. It's not something that could be different. It's a fundamental constant woven into the fabric of reality itself. Space and time are not separate currencies. They're two ways of measuring the same unified thing, space-time, and the speed of light is the number that relates them. Now watch this. If space and time are connected, if they're part of one thing, then when you move through space, you're also moving through time. Always. You're always moving through space-time at the same rate. Always. Every object in the universe, every particle, every person is moving through space-time at exactly the speed of light. Right now. You, me, everyone. We're all moving through space-time at light speed. Wait, what? How can that be? You're sitting still right now. You're not moving through space at light speed? That's true. You're not moving through space. You're moving through time. You're sitting still in space, so all your motion through space-time is directed along the time axis. You're moving through time at the maximum rate, which happens to be the speed of light. Here's the picture. Imagine space-time as a combination of two directions, space and time. Every object has a velocity through space-time, and that velocity is always the same magnitude, the speed of light, always. But you can point that velocity in different directions. You can point it all toward time, which means you're sitting still in space. Or you can point some of it toward space and some toward time, which means you're moving through space, but more slowly through time. The total always adds up to the speed of light. This is why nothing can go faster than light through space. Because if you're going at light speed through space, then all your motion through space-time is directed along the space axis. There's none left for time. You're using up all your motion budget on space. And since the total velocity through space-time is fixed, you can't go any faster. The speed of light isn't a speed limit. It's the speed. It's the only speed anything ever moves through space-time. Let me say that again because it's the most important thing. You're always moving through space-time at the speed of light. When you're sitting still, you're moving through time at light speed. When you're moving through space, you're diverting some of that motion from time into space. The faster you go through space, the slower you go through time, and the limit is reached when all your motion is through space and none through time. That's the speed of light. This is why time dilation happens. This is why clocks slow down when they move. It's not some weird effect. It's not magic. It's just geometry. When you move through space, you're tilting your velocity vector in space-time. You're pointing less of it toward time and more toward space, so you experience less time. Your clock ticks slower. Not because motion affects clocks, but because motion is literally movement through space-time in a different direction. Feynman understood this deeply. He had this incredible ability to see through the mathematics to the physical picture underneath. And what he saw was that the speed of light isn't really about light at all. Light just happens to be the thing that moves at this speed because light has no mass. Massless particles always move at the speed of light through space because they can't move through time. They have to put all their space-time motion into space. That's what it means to be massless. Massive particles like you and me, we move through time. We have to. Because we have mass, we can't put all our motion into space. Some of it has to be directed toward time. And the more mass you have, the more locked into time you are, the harder it is to redirect your motion toward space. Now here's where it gets really interesting. You know that famous equation, E equals mc squared? Energy equals mass times the speed of light squared. That equation is telling you something profound. It's telling you that mass and energy are the same thing. They're interchangeable. And the conversion factor between them is the speed of light squared. Again, the speed of light shows up as the fundamental conversion factor. But why squared? Why c squared? Here's why. The speed of light is the exchange rate between space and time, between distance and duration. But energy is about motion through space and time. It's about momentum and change. So when you convert between mass and energy, you need to account for both space and time. You need the speed of light twice. Once for space, once for time. That's why it's squared. E equals mc squared is telling you that mass is frozen energy. It's energy that's not moving through space, energy that's just sitting there moving through time. And when you want to release that energy, When you want to convert it into motion, you multiply by c². You use the speed of light as the conversion factor, twice. This is why nuclear weapons are so powerful. This is why the sun shines. Because when you convert even a tiny amount of mass into energy, you multiply by a huge number. The speed of light is big. The speed of light squared is enormous. A single kilogram of mass, if you could convert it completely to energy, would release 90 quadrillion joules. That's the energy of 21 megatons of TNT, from 1 kilogram, because c² is that big. But let's get back to the speed limit. Because now you might be wondering, okay, I understand that the speed of light is fundamental, that it's woven into space-time, but why can't we break it? What actually happens if you try to go faster? Here's what happens. You can't. Not you can't because it's too hard. You can't because it's incoherent. It's like asking what's north of the North Pole. The question doesn't make sense. Let me explain. Remember, you're always moving through space-time at the speed of light. Always. That's fixed. That's not changeable. Now, when you accelerate, what you're doing is changing the direction of your motion through space-time. You're tilting your velocity vector. You're pointing more toward space, less toward time. But there's a limit to how much you can tilt. The limit is reached when you're moving entirely through space and not through time at all. That's the speed of light. Can you tilt past that? Can you point your vector beyond the space axis? No, because then you'd be moving backward through time, and that's not how causality works. The universe doesn't allow backward time motion for massive objects. The structure of space-time itself prevents it. But wait, you might say. What if I just keep accelerating? What if I keep pushing? I have a rocket, I have fuel, I keep firing the engines. Don't I keep speeding up? Yes, you do. But here's the catch. As you approach the speed of light, your mass increases. From the perspective of an outside observer, you get heavier and heavier. It takes more and more energy to accelerate you further. And as you approach light speed, your mass approaches infinity. This is not a practical problem. This is not an engineering challenge. This is a fundamental feature of reality. As you go faster, your energy goes into increasing your mass more than your speed. You can pump infinite energy into acceleration, and you'll never quite reach light speed, because all that energy keeps making you heavier, and heavier things are harder to accelerate. From your perspective inside the rocket, it feels different. You don't feel heavier. You just notice that the universe outside seems different. Distances contract. Time dilates. The stars ahead of you shift color. But you never feel like you're approaching a barrier. You never feel like you're hitting a wall. You just keep accelerating and the universe keeps changing around you. And you never quite reach that limit where you're moving entirely through space. Feynman had a beautiful way of explaining this. He said, "Imagine you're walking north. You can walk north as much as you want. But you can never reach the point where north stops making sense. You can walk to the North Pole, but even there, north still has meaning. It's the direction you were walking. The speed of light is like that. It's not a wall you hit. It's the limiting case of a process that never completes. You can approach it. You can get closer and closer. But you never arrive because arriving would mean leaving space-time entirely." Now let's talk about something most people get confused about. They ask, if nothing can go faster than light, how did the universe expand faster than light during the Big Bang? How can distant galaxies be moving away from us faster than light? Doesn't that break the rule? No, because the rule isn't about space expanding. The rule is about objects moving through space. Space itself can expand as fast as it wants. There's no speed limit on the expansion of space because space isn't moving through space-time. Space is space-time. Think about it this way. Imagine you draw two dots on a balloon. Now inflate the balloon. The dots move apart. But are the dots moving across the surface of the balloon? No. The surface itself is expanding. The dots are just being carried along. They're not moving through space. Space is expanding between them. That's what's happening with the universe. Distant galaxies aren't moving through space faster than light. Space itself is expanding between us and them. and space can expand at any rate. There's no limit. The speed of light limits motion through space, not the expansion of space itself. This is subtle. This confuses even smart people. But Feynman would have loved this distinction. He would have drawn a little diagram, shown you the difference, made it click in your mind. Because the key to understanding physics is knowing what categories things belong to. Galaxies moving through space? Speed limit applies. Space expanding? No limit. Here's another question people ask. Why is the speed of light this particular number? Why 186,000 miles per second and not something else? Why not 1,000,000 miles per second? Why not 1,000,000,000? And here's the answer. The number is arbitrary. It depends on what units you're using. Miles, meters, seconds, these are human inventions. If you measured in different units, you'd get a different number. What matters is not the number. What matters is the ratio, the relationship between space and time. In fact, physicists often use units where the speed of light is just 1, not 186,000, not 300 million, just 1. In these units, 1 second of time equals 1 light second of distance. Space and time have the same units. They're measured the same way, because they're the same thing, and the speed of light becomes just a conversion factor, like saying 1 foot equals 12 inches. It's not about the numbers, it's about the relationship. Feynman often worked in these units. He called them natural units. And in natural units, the speed of light is 1, and E equals mc squared becomes just E equals m. Energy equals mass. Period. No conversion factor needed because energy and mass are already in the same units. Because fundamentally they're the same thing. This reveals something profound. The speed of light isn't a property of light. It's a property of spacetime itself. It's the fundamental exchange rate built into reality. And light just happens to travel at this speed because light is massless, because photons don't experience time, because they put all their motion through spacetime into spatial motion. Now watch this. Everything I've told you so far leads to something even stranger, something Feynman spent years thinking about. If the speed of light is the maximum, if nothing can go faster, then how does causality work? How do causes lead to effects? How does information propagate? Here's the answer. Causality propagates at the speed of light. Not faster, not slower. Exactly at the speed of light. When something happens here, it takes time for that event to affect things over there, and the time it takes is exactly the time it takes for light to travel that distance. The universe has a built-in delay, a speed limit on cause and effect itself. This is why relativity preserves causality. This is why you can't send information backward in time, because if you could move faster than light, you could create situations where effects precede causes, where you receive a message before it's sent, where you shoot your own grandfather. The speed limit protects the logical structure of reality. Feynman worked this out in detail. He showed that the equations of physics, the fundamental equations describing how particles interact, all respect this speed limit. Not because we built it in, but because the mathematics demands it. If you try to write down equations where causes can propagate faster than light, you get nonsense. You get contradictions. The universe doesn't allow it. Here's the deep part. The speed of light limit isn't a law we discovered. It's a consequence of the structure of space-time itself. It emerges from the mathematics of special relativity, from the requirement that physics be the same for everyone, regardless of how fast they're moving, from the insistence that causality be preserved. Einstein figured this out in 1905. He started with 2 simple postulates. First, the laws of physics are the same for everyone. Second, the speed of light is the same for everyone. From just these 2 ideas, he derived all of special relativity. Time dilation, length contraction, mass-energy equivalence, the speed limit. All of it, just from those 2 assumptions. And Feynman took it further. He showed how quantum mechanics fits into this picture. He developed quantum field theory, which describes how particles interact while respecting the speed limit. He invented Feynman diagrams, little pictures that show particles exchanging force carriers, photons and gluons and bosons, all propagating at or below the speed of light. Every interaction, every force, every cause and effect in the universe happens through particles moving at or below light speed. Gravity propagates at light speed. Electromagnetic forces propagate at light speed. The strong and weak nuclear forces propagate at light speed. Everything respects the limit, because the limit is built into the fabric of reality. But here's something that will really bend your mind. From a photon's perspective, from light's perspective, time doesn't pass at all. A photon emitted from a star 1 billion light-years away, from its own perspective, arrives at your eye instantly. Zero time elapsed. Because the photon is moving at light speed through space, it's not moving through time at all. For the photon, departure and arrival are the same moment. This is what it means to move at the speed of light. You don't experience time. The entire history of the universe, from your perspective, happens in an instant. You exist in a timeless state, frozen at the moment of creation and destruction simultaneously. We can't experience this. We have mass. We move through time. We're locked into causality. But light, massless light, experiences something completely outside our understanding. A state where time doesn't exist, where past and future collapse into a single moment. Feynman thought deeply about this. He wondered what it would be like to be a photon, and he realized you can't even ask the question coherently. A photon doesn't have a perspective. It doesn't have experiences. It doesn't have a reference frame in the usual sense. The mathematics breaks down. You can't do relativity from the photon's point of view because there is no photon's point of view. Time doesn't exist for photons, and without time, there's no experience, no perspective, no what it's like. This brings us to something crucial, something most people miss. The speed limit isn't about speed, it's about structure. It's about the geometry of spacetime. It's about the relationship between cause and effect, between past and future, between what's possible and what's not. When you move faster through space, you move slower through time. When you move at maximum speed through space, you don't move through time at all. That's the limit. Not because you hit a wall, but because you've rotated your motion entirely into the spatial dimension. There's no more time direction to rotate into. You've used it all up. This is why you can't go faster. Not because of engineering, not because of power, but because going faster would mean moving backward through time. And backward time motion would break causality, would allow effects before causes, would create logical contradictions. And the universe doesn't allow logical contradictions. Reality is consistent with itself. Feynman once said, "Nature uses only the longest threads to weave her patterns, so each small piece of her fabric reveals the organization of the entire tapestry." The speed of light is one of those threads. It weaves through everything. Relativity, quantum mechanics, causality, the structure of space-time itself. Pull on it and the whole tapestry reveals itself. You can't go faster than light because light speed isn't a speed. It's the shape of reality. It's the rate at which space-time itself flows. It's the fundamental conversion factor between space and time, between energy and mass, between cause and effect. You can't break it because you can't break mathematics. You can't break geometry. You can't break the logical structure of existence itself. And here's what makes this beautiful. Here's what Feynman loved about physics. We figured this out. Humans, tiny creatures on a tiny planet. We looked at the stars. We measured the speed of light. We noticed it never changes. And from that one weird fact, we unraveled the structure of space-time. We discovered that space and time are unified. That mass and energy are equivalent. That motion has a maximum not because of barriers, but because of geometry. We did this with mathematics, with careful experiments, with thought experiments and equations and an unwavering commitment to following logic wherever it leads. We can't go faster than light, but we can understand why. We can see the shape of the constraint. We can grasp the deep structure underneath. That's what physics is. Not just collecting facts, not just measuring numbers, but understanding the patterns, seeing how everything fits together, recognizing that the universe is mathematical, logical, consistent with itself. And we, made of atoms, animated by electrical impulses, we can comprehend it. Feynman spent his life teaching this. Not just the equations, but the understanding, the intuition, the sense of wonder that comes from seeing reality clearly. He knew that physics isn't about memorizing formulas. It's about seeing the world as it actually is, strange and beautiful and governed by principles we can understand. The speed of light has a limit because space-time is unified, because motion through space is rotation through space-time, because time and space trade off against each other, because causality must be preserved, because reality is consistent. And you, right now, are moving through space-time at the speed of light. All your motion directed through time because you're sitting still in space. Every second that passes is you traveling 1 light second through time. You're moving at the cosmic speed limit right now. You've been doing it your whole life. You just never realized it. That's the truth. That's what Feynman found. That's what will collapse your mind if you think about it deeply enough. Not that there's a speed limit, but that speed itself is an illusion. What's real is motion through space-time, and that motion has one rate. Always. For everyone. For everything. The speed of light isn't the maximum speed through space. It's the only speed through space-time, and we're all traveling it. Right now. Forever. Space and time are one. Motion and rest are relative. The speed limit is geometry. And reality is stranger and deeper and more beautiful than anyone imagined until Einstein and Feynman showed us the truth. The universe doesn't have a speed limit because someone posted a sign. The universe has a speed limit because of what the universe is. Space-time. Unified, consistent, mathematical, real. And we figured it out. That's the real miracle. That consciousness can understand the framework it's embedded in. That thought can grasp the structure of reality. That humans can know why speed has a limit and what that limit means and how it shapes everything we are and everything we'll ever be. That's physics. That's what Feynman gave us. Not just knowledge, but understanding. Deep, clear, beautiful understanding of the way things actually are. The speed of light isn't fast. The speed of light is the conversion factor between space and time, between energy and mass, between cause and effect. It's woven into reality itself. And nothing can exceed it. Not because of force, but because of logic, because of geometry, because of the structure of existence itself. That's the answer. That's the truth. That's what will collapse your mind if you let it. Speed has a limit because space-time is what it is. And what it is unified, consistent, and knowable. Feynman knew it. Einstein knew it. And now you know it too.